Okay, here we have the review. This is 4.6, so we're reviewing everything from 4.1 to 4.5, getting ready for the quiz that we have upcoming for polynomials. First problem is to use synthetic division to perform this operation. So it looks like I'm trying to find if x minus 2 is a factor, which means I'm testing if x equal 2 is a solution. So I'm going to write a 2. I'm going to set up this synthetic division. And then I'll have a 3, -2, 1, 0, -12. So I have to account for everything. That's my x to the fourth, my x cubed, my x squared, my x, and my constant. Getting that 0 is very important and getting this done correctly. So bring the 3 down. 2 times 3 is 6. 6 minus 2 is 4. 2 times 4 is 8. Add 1 to get 9. 2 times 9 is 18. Add to get 18. 2 times 18 is 36. Minus 12 is 24. Okay? So this tells me that x minus 2 is not a factor. Okay? So my answer, I can read my answer off of here. So this corresponds to my x cubed, my x squared, my x, my constant, and my remainder. So the answer is going to be 3x cubed plus 4x squared plus 9x plus 18 plus a remainder of 24. Okay, so synthetic division, here I got a non-zero remainder. So I did not find a factor, and then I see the solution of the division is indicated up there. Okay. Number 2, I want to completely factor this polynomial given that x plus 2 is a factor. So that means that when I do synthetic division with -2, I should find x plus 2 to be a factor. So 6, and then 19, 16, and 4. Bring the 6 down, and I multiply to get -12, add to get 7, -14, add to get 2, -4, and I get a 0. So that means that my polynomial is going to be what, x plus 2 times, and I read that information right there. That is 6x squared plus 7x plus 2. So now all I need to do is to factor that particular case. So 6x squared plus 7x plus 2. I need to find two numbers that multiply to give me a 12 and add to give me a 7. Those numbers should be 3 and 4. So I'm going to rewrite this as 6x squared plus 3x plus 4x plus 2. If I factor out a 3x, I get 2x plus 1 plus 2 times 2x plus 1. So this is 3x plus 2 times 2x plus 1. So my final answer is x plus 2, 3x plus 2, and 2x plus 1. So that's the complete factorization of the polynomial. Number 3, I'm describing the end behavior of these polynomials. Okay, so to know the end behavior, I need to know the degree and the leading coefficient. So in this first one, so if I look at the degree, so I'm going to have a squared and then an x and an x. So the degree is 4, and the leading coefficient is going to be, I get a negative, and then I've got a 1 in front of that x, and a 1 and a 1. Leading coefficient is -1. So I've got an even degree polynomial, and I've got a negative coefficient, So the end behavior is going to look like this, okay? So as my x values go to negative infinity, my y values go to negative infinity. And then as my y values go to positive infinity, excuse me, my x values go to positive infinity, the y values go to negative infinity, okay? So that's this one. If I look at the next one here, part B, the degree is going to be, I have 1, 2, 3, 4, 5. This is a fifth degree polynomial, and the leading coefficient is going to be a 1 for that first term, a 1 squared, and a negative 1. So negative 1 is the leading coefficient. So I've got an odd degree with a negative coefficient. So when I have an odd degree negative, it's going to do this, okay? So that means as I go to negative infinity, my y values go to infinity. As I go to positive infinity, the y values go to negative infinity, okay? Number 4, again using synthetic division to do complete factoring. So here I start with a fourth degree, but I know two of the factors. So I've got x plus 5 and x minus 7 as factors. So let's start with the negative 5, and let's do the first synthetic division. So that will be 1, 1, negative 39, negative 109, negative 70. So bring the 1 down, multiply to get negative 5, add to get negative 4. Multiply to get 20, and then you subtract that to get negative 19. And then 5 times 19, that's going to be 95. And you add that to get 14, negative 14. Negative 5 times negative 14 is 70. That adds to give me 0. Now, I need to do this synthetic division one more time with 7. Okay, so if I bring the 1 down, 1 times 7, 7 minus 4 is 3. 7 times 3 is 21. Add those to get 2. 7 times 2 is 14. Add that to get 0. Okay? And if remember, this was my x to the fourth term. That was my x cubed term. This is my x squared term. Okay? So I now know that this polynomial is x plus 5, x minus 7. Those are the two factors that I found. And then what did I get in my final answer here? That's x squared plus 3x plus 2. And to factor this, I need two numbers that multiply to give me 2 and add to give me 3. Those are a 2 and a 1. So my final answer is x plus 5, x minus 7, and then x plus 2, x plus 1. So that's the final factorization of that polynomial. Okay, that's the end of page 1.